Hello everyone, myself Dr. Manoj Kumar, working as an assistant professor in Department of PC at MLR Institute of Technology, Hyderabad. Today I am going to deliver a lecture talk on capacitive transducer. This is overview of my presentation. First of all, I would like to discuss the basic concepts of a capacitive transducers. Thereafter, I'll be taking the classification, different types of capacitive transducer, construction, how to construct a capacitive transducer, working principle of a capacitive transducer, and finally, I am going to take some of the application of capacitive transducer. So, basic concept of capacitive transducer. As the name is suggesting, capacitive transducer. In earlier lecture, we discussed about resistive transducer. So, there was change earlier in resistive transducer, there was change in resistance whenever some physical quantity is detected. And in capacitive transducer, here we will see that there is change in capacitance whenever any physical quantity is detected. So, this is the basic difference. Capacitive transducer means there will be change in capacitance whenever some physical quantity is detected. But in resistive transducer, earlier which we discussed, there was change in resistance whenever the physical quantity was detected. So, here we will see how there is change in capacitance whenever there is physical quantity is sensed by a capacitive transducer. So, first of all, we would like to discuss the definition of a capacitive transducer. A capacitive transducer is nothing but it will sense physical quantities like displacement, pressure, humidity by changing the capacitance of a capacitive transducer. So, the thing is that there will be change in capacitance whenever some physical quantities like displacement, pressure, humidity is detected. What is its purpose? It measures the change in capacitance caused by the variation in physical parameters. So, the interesting thing here is that how the capacitive transducer, there is change in capacitance whenever there is physical quantity detected like displacement, pressure, humidity. We will see in the upcoming slides. What are the key parameters of this capacitive transducer? First and foremost is sensitivity. Sensitivity of a capacitive transducer is nothing but the capacitance change per unit input, per unit physical quantity input. So, to have the good capacitive transducer, the sensitivity of that capacitive transducer should be very high. Then only we can get very highly accurate result. Second point is that linearity. That capacitive transducer should be highly linear. Highly linear means there should be proportional change in the input and output. So, if you are varying some input here, suppose delta, by delta only there will be change in the output. Then only we can say that it is linear. And linear property of a capacitive transducer is highly desirable. So, we have to try that whenever we construct any capacitive transducer, there should be perfect linear relationship between the input. Input here denotes the physical quantities like pressure, displacement, humidity, etc. And output here denotes the change in capacitance. So, there should be a perfect relation between the change in input and change in output. Perfect means it should be highly linear. Then only we can say that capacitive transducer will work in the satisfactory condition. Otherwise, it will show some error. Stability. Stability is very much required because stability of any transducer should not be impacted by the environmental conditions. So already we discussed, we can classify the capacitive transducer under two categories, based on application and based on its construction style. Based on application, we have displacement sensors, which will measure the position or movement of any object. So, capacitive transducer can be also used to measure the position or movement of any object, which is also known as displacement sensor. Second classification is that capacitive transducer may be a pressure sensor, which will detect the pressure in terms of change in capacitance. Third is that humidity sensors, which measures the atmospheric humidity. This is humidity sensors can be also a capacitive type of transducer. Based on construction, we can classify the capacitive transducer as parallel plate transducer. We have cylindrical transducer and we have variable dielectric transducer. In parallel plate, we have to keep two plates parallel to each other, and whenever some displacement is detected, there will be change in the distance between two plates, and whenever there is change between whenever there is change of distance between two plates, there will be change in the capacitance. And here we can see that variable dielectric transducer. So suppose we have capacitor and we know that there is a dielectric in between this. So if you change the position of this dielectric, there will be change in the capacitance of this transducer. So based on construction, we can make parallel plate transducer, cylindrical transducer and variable dielectric transducer. So these were the classification of a capacitive transducer. What are the key components? How to construct a capacitive transducer? This is the main thing to understand. How to construct? So first thing, we have to understand what are the key components. So key components in a capacitive transducers are plates. Plates means metal plates, not any plastic or nothing. Metal plates which should be highly conductive. First requirement to make the capacitive transducer. Second requirement is that dielectric material. As we know that in capacitor we have two plates and between two plates we have dielectric material. So second requirement is that we should have a good dielectric material. It may be air or it may be some plastic materials. So plates, dielectric material. Third thing is that sensing mechanism. We should develop a system based on plates and dielectric material that whenever some physical input is detected, there is change in distance between two plates or area of two plates or dielectric between two plates. If you develop the sensing mechanism which can detect the physical input by varying the distance between two plates, area of the plate or dielectric between two plates. This is the third requirement to construct any capacitive transducer. The fourth requirement is obviously housing. Housing is nothing but a packaging which will protect its internal component. So by using these four technique or four components, we can easily construct a capacitive transducers. So in the animation we can see in the first case what is happening. The distance between two plates is changing. Suppose this pink purple color denotes two plates of a capacitor, and whenever some force is applied, see what is happening. the distance between two plates are changing. Whenever the distance between two plates changes, obviously the capacitance always changes. How? Let us understand how the distance affect the capacitance of a capacitor. As we know that capacitance is given by epsilon A by D. This is constant, this is area of plate, and this is distance between two plate. So whenever the distance between two plate will changes, obviously the capacitance of the capacitor will change, which is happening here. Suppose from here what will happen, force is being applied. Force is nothing but the physical quantities, and whenever the force is applied, there is change in the distance between two plates. Obviously if the distance between two plates changes, the capacitance value also changes, and when capacitance changes, the voltage across the capacitor also changes, which is shown by the voltmeter. So what is happening? First we are applying the force. Force is being converted into change in capacitance. This change in capacitance giving the change in voltage by using this formula. So here we can see that indirectly this force, first it is converted into capacitance, and this change in capacitance is easily calibrated in terms of voltage, and we can easily see the magnitude of force in terms of change in capacitance and change in voltage. So in this way we can design a capacitive transducer. So already we have discussed some of the working principle of capacitive transducer. Just we have to remember this formula. The capacitance of a capacitor is given by epsilon A by D. This is constant. This is the dielectric constant. This is area of plate, and this is the distance between two plates. So whenever the area changes or distance between two plates changes or this dielectric material changes, obviously the capacitance will change depending on the magnitude of physical quantities. Depending on the magnitude of physical quantity. So our aim is that whatever physical quantities like displacement, temperature, pressure, humidity, anything we apply to capacitive transducer, there must be a proportional change in its capacitance. And whenever there is proportional change in capacitance, we can easily calibrate this capacitance in terms of voltage and finally for display. So in this way we can detect the physical quantities by using the capacitive transducer. So what are the application? We can use in the industrial automation for displacement and position in machineries. In aerospace we can use for pressure monitoring, for respiratory heartbeat and respiratory monitors, and in for consumer electronic we can have touch screen proximity sensor using a capacitive transducer. So whatever the earlier touch screen was there, those all were based on the capacitive transducer. Capacitive transducers has lot of application. Okay, so some of the application I have highlighted. Thank you.